I'm sure you're a pro at dividing all kinds of numbers, decimals, fractions, integers. But do you know how to divide with exponents? Guess what? Today's your lucky day. In this lesson, we're going to explore how to do division with exponents. Let's start with a quick refresher on exponents. Exponents give us a shorter way to write long multiplication expressions. The number that's being multiplied is called the base, and the number it is raised to is called the exponent. The exponent tells us how many times the base is used as a factor. In this example, 2 is the base and 5 is the exponent. You can read this as 2 to the 5th power. To simplify this expression, we use the base, 2, as a factor 5 times, since the exponent is 5. 2 times 2 times 2 times 2 times 2 is 32. So 2 to the 5th power has a value of 32. Alright, so we know what exponents are and how they work, but how do we divide them? Let's look at this problem to figure it out. Here we have 2 to the 5th power divided by 2 to the 2nd power. We can write 2 to the 5th power as 2 times 2 times 2 times 2 times 2, and 2 to the 2nd power as 2 times 2. That's a lot of 2's. Luckily, we know that 2 divided by 2 equals 1, so each time we have a 2 in the numerator and a matching 2 in the denominator, they cancel each other out. That leaves us with 3 2's remaining, which we can write as 2 to the 3rd power. Now, maybe you're thinking this process could take a while if the exponents we're dealing with are large. I agree. So let's take another look at the problem we just completed to see if there's a more efficient method. Remember, 2 to the 5th power divided by 2 to the 2nd power simplifies to 2 to the 3rd power. Notice that if we subtract the exponents, 5 minus 2, we also get an exponent of 3. This doesn't just work for this problem, but anytime we divide with exponents. It's important to know, though, that this rule doesn't work when the exponents have a different base. That means I can't subtract the exponents in this problem, for example, because one has a base of 7 and the other has a base of 2. And that makes sense, right? Because when we write it out, there are no like numbers in the numerator and denominator to cancel one another out. Let's try some more examples together, starting with 30 to the 12th power divided by 30 to the 4th power. These both have a base of 30, so we can subtract the exponents to simplify the expression. 12 minus 4 is 8, so this simplifies to 30 to the 8th power. The exponents in this problem also have the same base. So since 15 minus 5 is 10, this expression simplifies to 245 to the 10th power. What about this problem? When we subtract the exponents here, we get 0. So what is 119 to the 0th power? Well, any number to the 0th power is 1. We can also see this by using our fraction knowledge. Since 119 to the 6th power divided by 119 to the 6th power is a number divided by itself, we know that the answer must be 1. Do you see anything different about this problem? I bet you noticed that when we subtract the exponents, we get a negative exponent, -3 to be exact. So 2 to the 2nd power divided by 2 to the 5th power is equal to 2 to the -3rd power. But how do negative exponents work? Let's take another look at 2 to the 2nd power divided by 2 to the 5th power. Remember, we can expand the exponents and cancel out 2 2's in the numerator and denominator. Looking at it this way, the answer is 1 over 2 to the 3rd power, since there are 3 2's remaining in the denominator. And that's just what 2 to the -3rd power means. So, we can write 2 to the -3rd power as 1 over 2 to the 3rd power. We'll try a couple more involving negative exponents to make sure you've got the hang of it. When we subtract the exponents in the problem 75 to the 10th power divided by 75 to the 14th power, we get 75 to the -4th power. Remember, when we have a negative exponent, we can write it as a positive exponent in the denominator. This means our answer is a fraction, 1 over 75 to the 4th power. Let's try just one more before you go. 768 to the 8th power divided by 768 to the 17th power. 8 minus 17 is -9, so we get 768 to the -9th power. We write this as 1 over 768 to the 9th power. Nice work! Now you can add knowing how to divide exponents to your list of numbers you know how to divide.